Number 5 in 2.7, you'll notice this box right here that says GU, and I'm not sure if we've talked about that in class or not. Anytime you see a problem in the book with that GU box right there, that means graphing utility. That's basically telling you, hey, go ahead and use your graphing calculator on this one because we're about to ask you a question about a function that you're not supposed to be able to deal with on your own. So this one right here is a rational function. F of x is equal to x cubed over x cubed plus x. So they want you, notice, to investigate what's going on right here, but they're asking you 3 questions, and the third one is really the important one. What are the horizontal asymptotes of f? And that's actually, interestingly, the problem we should be able to answer without our calculator, because we have learned hard and fast rules for the horizontal asymptotes of rational functions. So what's going on right here, guys? Our numerator has a degree of 3. Our denominator also has a degree of 3. So this is the case where the numerator and the denominator are tied in their degree. And so the horizontal asymptote right then, horizontal asymptote, is the line y equals a over b. A is the leading coefficient of your numerator, which is a 1 in this case. B is the leading coefficient of the denominator, which in this case is also a 1. So there's the answer, guys. The horizontal asymptote of this function, I would be shocked to find out if it was anything different, is y equals 1. But I think they want you to do a little exploration on your calculator. So it says to make a table of values there and also to plot the graph. I didn't read this that carefully before I got started, so I got ready to do the graph here already. So when I plot this thing, okay, I get this interesting looking function right here, and I suppose I could go further off. Ooh, can I do this here? I thought I could, but maybe not with my pencil here. What if I just use my finger? There you go. I could pull this thing further off to the right, but boy, I think I get what's happening, and I think the same thing happens over here on the left. So it really looks like what we just wrote down was correct, that we've got a horizontal asymptote here of y equals 1. Let me just put that in real quick. Why am I on f3 of x and not f2? Oh, that was supposed to... Oh, I didn't clear that out. Sorry. So what if I were to put now f1 of x is equal to 1? Okay. That blue line is what I think my horizontal asymptote was, and as I zoom in on this, yeah, guys, this does exactly what I thought it would do. It looks like that red curve, which is our actual function here, is getting closer and closer and closer to that horizontal asymptote, but it doesn't look right now like it's ever actually going to hit it. Okay, so with that in mind, let me go and I'll do part B. I guess I'm doing this completely backwards. So part B was to plot the graph of what was going on right here, and it kind of looked like we had an asymptote right here at 1, and it looked like we had a function that dipped down, did something like this, and then came up and the following. Now, the one thing I'm pretty sure that I goofed up, though, let me go back and look at my graph, is that it sure looked to me like this graph passed through the origin. Let me try to find that again and see if that at least is what it appears to do. But I'm wondering if you guys already know where I'm going with this. I should probably shrink this back down. Yeah, it definitely looks like it passes through the origin, but if we look at the actual function, x cubed over x cubed plus x, hopefully you guys realize that if I put a 0 in for x, my denominator becomes 0, and incidentally so is my numerator, which means that we actually have a hole right there at 0, 0. So that's what the part B is going to look like. Okay, and we got C. Let's talk about A real quick. So let's make a table of values for F, as X is going to be 50, 100, 500, and 1,000 here. So I tell you what, real quick, if I wanted to do this, what I would probably do here, I mean, they even said make a table. So I'm going to add a page to my document here, and I'm going to do lists and spreadsheets. That's how we do tables here. And I'm going to start off now with an X value of, it's saying, now, let's put a, well, why can't I? There we go. There's my keypad. Let me put a 50 in there. And while I'm here, they wanted 100 next. And then I forgot what they wanted. 50, 100, 500, and 1,000. I'll worry about the negatives in just a second here. So 500, gotcha. And then 1,000, gotcha. And then what we wanted here was that function, which I believe I put in as f2 of x. We wanted that evaluated at those 4a values here. So I'm going to say I want to hit an equals sign right here. I want you to evaluate the function f2 at the previous x value there, which is in cell A1. And there's an answer we got. And if I were to copy and paste that here, copy and then go here and say, let's paste all of that. Okay. That's what we've got. Now, unfortunately, it's giving me fractions right there, which makes it harder for me to see the actual answer. And there's a way to do this, darn it, and I can't remember how to get that column wider here on my iPad. But if I click on the actual cell, oh shoot, nowhere does it tell me that. How about settings right here, guys? What if I did real or calculation mode instead of auto? Let me turn that to approximate. And then go back and say, ooh, I'm going to regret this, but make default and hit OK. Okay, that works a little bit better. Now you can start to see that these decimal numbers that I've got are 0.9996, 99990, and now all of a sudden 99999. Notice there's still some dots right there. And then I get the same thing at 1,000. And again, I'm sorry, guys, I wish I could make this column bigger, but I'm not quite sure. I'm sure there's a way to do that. There is on every spreadsheet I've ever seen. Nope. There you go. I'm not sure how to do that here. Anyway, I think we get the point right there. Now, real quick, if we were to make these numbers negative, I don't think you're going to see a difference. Now, maybe I can explain to you why. If we take a look at the original function here, if we had put in 50 and cubed it, we're going to get a really large positive number. I think that's 125,000. If we make that negative 50, now that numerator becomes the opposite of that, negative 125,000. But you're doing the exact same thing down here on the bottom. So this numerator turns negative, and so does the denominator, and the negative divided by negative is still going to get you a positive. So for A, if I wanted to write down my answer right here, if I made a table, I'm going to go horizontal right here of x and then f of x. We'll go this route right here. And it doesn't matter whether we do plus or minus 50, so I can put them in the same spot in the table, and then 100, and then plus or minus 500, and then plus or minus 1,000. I thought here we got 0.99. I better look at this again. That was 9996. Okay, gotcha. And then 0.99990. And then after that, I just got, what, 5 nines, I think, for both of these numbers. Now, on your calculator, if you can figure out a way to get that column wider and get a little bit more precision in those numbers, that would be great. Either way, I think you're going to see the important takeaway they wanted here from part C, and that's that your horizontal asymptote is y equals 1. As x is approaching infinity, that's the important thing they wanted you guys to see right here. Actually, as x is approaching either positive or negative infinity, then what we see from these values right here is that f of x is approaching positive 1 as x approaches positive or negative infinity. So that's what was going on. That's what they were hoping you guys would take away from section 2.7, problem number 5.